So this is just a quick little video walking through what we went over in class the other day um, about writing formulas and sort of breaking it down. So how to attack this the formula writing worksheet number one. So first, there's four basic, and these, by the way, are also attached in this assignment, these notes, but there's four basic categories that we've been learning: ionic, covalent, acids, and hydrates. Right? The blue stuff on here is how you tell the difference this is all when you're given the names and you're trying to write the formula. So the easy ones, hydrates end in a prefix like mono, di, tri, or whatever, and then hydrate. So for example, on the homework, like number 7, calcium chloride trihydrate, that's a hydrate. Okay. Acids obviously are very easy. They literally end in the word acid. Covalent, you can tell they're made of two non-metals or not metals, but also the easier way when you're given the name is in the name for a covalent, it will have the prefixes mono, di, tri, those. The only things that use prefixes are the covalents and the ending of the hydrate part. So if it's not the ending of a hydrate, if it's not a hydrate, and it uses the mono, di, tri stuff, it has to be covalent. Okay. And then an ionic one, if it's not one of these three, it'll be ionic. Ionic will start with a metal or ammonium, the only positive polyatomic that we're going to use. Okay. So the red information in here is sort of like breaking down how to do each type. Okay. So I'll go through it briefly here. Ionic uses charges in the crisscross method. So you need your periodic table and your polyatomic sheet. Okay. So like number 1 here is ionic. Okay. So what you're going to do is you're going to get the charges. Now, if it has a Roman numeral, that's the cation charge. So like copper, the reason it needs a Roman numeral is because if you look up copper on the periodic table, there's no charge. So they have to tell us the charge. That's what the Roman numeral is for. Roman numeral is always a positive charge. Copper is a +3. Sulfide, okay, if the anion ends in IDE, it's usually monatomic from the periodic table. There are some on the polyatomic sheet that end in ide, most notably hydroxide. That's a pretty common one. Okay, but most things that end in ide are from the periodic table. So sulfide is sulfur. Look it up. Sulfur is a -2. You look to see if you can reduce. If you can't reduce, if you can reduce, you reduce. And then after that, you're going to cross down. Okay, so we get Cu2S3. Now remember, when they're down here, they are not charged. This is just a method to figure out this. The numbers that are in subscripts are the numbers of atoms, not charges. There's no charges down here. If you're writing charges, they need to be up above, because any numbers down here should be atoms. They should not have any positive or negatives on them. Okay. All right. If your anion either ends in something other than IDE or it's not on the periodic table, then it will be a polyatomic, like here, the phosphate. And then you'd look up on this sheet and you'd find out what it is and you'd use that. So PO4 -3, then you do the crossing, reduce, all that. Right? Okay. Covalent. Ones that use prefixes, the mono, di, tri stuff. Okay, so like number 4, dichlorine pentafluoride. That's a covalent. There are no charges, no crossing on covalent. You don't use any of that. Very simply, the prefixes tell how many atoms of each element there are. If there's no prefix on the first element, there's one of them. So dichlorine means chlorine is Cl, their di is 2. Pentafluoride, fluoride is from fluorine, penta 5. That's it. No reducing, no charges, no crossing. Okay. All All right. Acids. All acids start with H plus. Okay, so like number 5 here, hydrophosphoric acid. We know it's an acid because it ends in acid, so it's H plus. It is our cation. The cation is always H plus. All right, if it has hydro, the anion is monatomic from the periodic table. So we have hydrophosphoric. That means the phosphoric is from phosphorus from the periodic table. So we looked that up. Phosphorus on the periodic table is -3. Okay, we use charges in crossing for acids. Cross down, we end with H3P. Okay. If there's no hydro, okay, so one like, let me see, here, carbonic acid. Okay, you still start with hydrogen. No hydro means the anion is polyatomic. You find the polyatomic with the element and ending in 8 on your sheet. So we look here, carbonic would mean carbonate. We have to look up carbonate on our polyatomic sheet. Carbonate is CO3 2 negative. Okay. We reduce if we can, we can't. We cross down. We get carbonic acid, H2CO3. Okay. All right. Last one, hydrates. Hydrates, the beginning part is ionic. So you do it exactly like an ionic. You use charges in crossing. Okay, so for example, number 7, calcium chloride trihydrate. So the beginning part here is ionic. So I'm going to get charges in crossing. So calcium, I look up on my periodic table. Calcium is a +2. Chloride, again, IDE, look up on the periodic table. Cl -1. Cross down. I get CaCl2. Okay, that's the beginning part. Excuse me. Then the ending, you end with a dot, a number that represents whatever the amount the prefix is in the name, and then H2O in place of the hydrate. So calcium chloride trihydrate. So dot, tri is 3, hydrate, I put in H2O, just like that. And there's your answer. CaCl2 dot 3H2O. All right. So that's the quick and dirty breakdown. Like I said, this set of notes is on the up on Classroom already for you. If you have any additional questions, let me know. Good luck.